Hi, welcome back to this video series on program synthesis. Today I'm going to talk about how to synthesize a program with some properties. We want to be able to use Boolean expressions and do arithmetic with Boolean expressions. Okay. For example, in the C programming language, we may do something like this: Z is equal to X less than Y. This is perfectly fine in the C language, right? If X is less than Y, Z will have value 1, otherwise Z will have value 0. But we can't do this, as far as I know, in SMT syntax. In SMT, the data types have to match, okay? If X and Y are bit vector types, Z must also be a bit vector, okay? In this case, you have to declare your Z also to be a Boolean type, because this is Boolean, okay? So so your Z has to be Boolean as well, otherwise it won't work with the SMT solvers, as far as I know. But in the C language, we can create Z to be an int. This is perfectly fine in C language, right? In C or in Java, this is perfectly fine. So you have a data type mismatch problem, and then we need probably in many example cases to be able to have this kind of expressions as part of the synthesis, right? To be able to synthesize programs which have this expression. Okay, so how do we handle it now? First, I will show you that it's difficult to put X less than Y and assign that to Z in SMT solvers. First, I will show you that. Okay. So what you're going to see now is my Z3 version, where I show that that indeed that is the problem. Okay. So consider this. What you're seeing here is basically Z3 model, right? I created 3 variables X, Y, and Z. I'm trying to do assignment statement here, right? What I'm trying to do is I'm trying to do Z equal to X less than Y. That's what I'm trying to do at this point, right? This is the meaning of the statement. But you will see down that it's not possible. When I try to run this, it shows that line number 6, sorts bool and the bit vector 32 are incompatible. So because it's clear that my my code has a bug in terms of how I compose the different types. This is Boolean type and this is bit vector type. So I can't do that. Of course, it will work if I change my Z to Boolean, but I don't want to do that. So which means that I can't use something like this as part of the synthesis, right? Suppose I would like to synthesize a program where I wanted to be able to do something like this, right? I can't do that because of mismatch. So I'll show you a small strategy, small trick that you may try to handle this problem where the types are mismatched, okay? So what you're going to see is my implementation of how I handle this problem of type mismatch. So yeah, let's see. Okay, so what you're seeing on your screen is a model of a grammar that we would like to synthesize, right? A model of the program we would like to synthesize based on this grammar. So this is the grammar. And the grammar itself is pretty much the same as what you used to see in my previous sessions. What is new at this point is this expression, bool to bit vector. Okay, so what I'm doing here is, if I am given a Boolean expression, so remember, less than or equal to are all Boolean expressions. So I will be able to convert a Boolean expression into a bit vector if my Boolean value is true, I'll consider this as 1, otherwise I consider this 0. So that's basically what I do. I create a new function called bool to bit vector, and that solves the problem. Okay. So I will use that to find the maximum of two numbers. Okay. So which is a simple problem, but you will see that I don't have if then else statement in my code when I synthesize this. Okay. I will first run this and then I'll come back to the specification so that we are sure that our program is actually indeed finding the maximum of two numbers. Okay. So the synthesizer is taking my grammar and trying to come up with an expression for us. Okay, so it came up with an expression and I will write it for you in plain English or in C-like syntax better, right? So what is this function really? The maximum function is basically doing f of x comma y, which is maximum of f is the max function, right? This is the max that you're seeing here. I just call it f. Okay, so what is it really doing? Let's start from the innermost statement, right? Okay, so we're doing a bitwise AND, that is the most inner one. Okay, that means I need to reserve some space here. So I'll do first less than or equal to. So is x less than or equal to y? Okay, that is the first part. And then we are doing Boolean to bit vector conversion. Okay, so remember this is a Boolean expression, right? So we can just ignore that bool to bit vector because we are allowed to use it in C language like this. So I will just ignore that bool to bit vector, basically replace it by whatever is here, right? And then we are doing also bitwise XOR between X and Y. Okay, so we do bitwise XOR between this XOR. Okay. Oh, sorry, it didn't come clear. Let me erase it. Okay. So what you're seeing here is now X XOR with Y, and then we are doing AND of these two. So this is the bitwise AND. Okay, bitwise AND. And this whole thing is now going through an XOR in the front. Okay, so this whole thing is an expression now, and we do an XOR of this whole thing. So this basically is your maximum of two numbers computed without using an if then else statement. In some rare machines, actually, usage of less than or equal to might produce a branch. So I'm not concerned about that at this point, but I'm only showing you how we automatically synthesized an if then else statement where this Boolean expression, this is, remember, this is Boolean, right? We just made use of this in this nice little trick, Boolean to bit vector conversion trick. And we treated that as a number. That's the reason why we were able to synthesize expressions of this form. Otherwise, we can't synthesize this expression. Okay. So now the question is, why would this be a correct answer? How do we know this is actually maximum of x comma y? Well, we can write a lot of test cases and try it and convince ourselves that's the case, or we can do more cool stuff, right? By just specifying what do we mean by maximum. Okay, sometimes specification is a pain. You can actually use programming by examples, which I discussed in my other videos. We give bunch of x's and y's, and it automatically synthesizes a generic formula like what you're seeing based on the x and y we gave, right, as well as the output. So in this case, I'm going to show you my somewhat a formal specification. It's not that formal, but it's just very lightweight. What you're seeing here is the spec, right? So what I'm saying is very simple. If x is less than y, the answer be y, because that's the meaning of max. Otherwise, the answer is x. Okay. So where are we using the spec? Here is the place where we are saying synthesis for me a max function, right? That's the function f. The function max better be the same as the spec. That's the reason I put an equal to. Okay. So it was able to use only the AND XOR bitwise negative, right? Basically put a negative number in front of a positive number, or if it is positive, put a negative. It's bitwise, not. What we actually truly introduced in this video session is this Boolean to bit vector conversion. Okay. Remember, it takes a Boolean as a data type, it gives you back a bit vector, which we can happily use. Otherwise, we are not able to add and do comparisons, because these are two different types. Okay, bit vector AND can only be performed between two types of bit vector. You can't do a bit vector between a Boolean type and a bit vector type. No, not possible. That's the reason I have introduced this little small trick. Okay. I hope you find this useful. Suppose you don't like this spec approach. Of course, you could use other techniques that we talked about, like the average. When I demonstrated about average, right, between two numbers, we trained it with a bunch of examples. Here, there's no specification. Remember, I just specified input-output pairs, a bunch of input-output pairs, and then you got the model synthesized automatically for you. The program synthesized automatically. All right, so that's basically it. And it's interesting that this small trick allows us now to synthesize C-like expressions, right? We are able to handle X less than Y conditional statements as part of the expression. Okay, that's the main thing I wanted to show to you. Thank you.